Now let's try another example. Chromium metal can be produced by this reaction. We've been told that 5 kilograms of aluminium is mixed with 20 kilograms of chromium oxide. Immediately, alarm bells should be going off. Ding, 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 ding. I've got too much information, so it must be a limiting reagent question. So, let's find the moles. The number of moles of aluminium is equal to a mass over a formula mass. Now, the problem is the mass is in kilograms, and we must convert it to grams before we start. So it's 5,000 grams over the formula mass is 26.98, which I got off the periodic table, and it comes out to 185.32 moles. Now I'm going to store that on my calculator. Now let's find the number of moles of chromium oxide, which is equal to a mass over a formula mass. Once again, it's in kilograms, so I must convert it to grams. So 20,000 grams over 152 is the formula mass of the periodic table, and it comes out 131.58 moles. I am once again going to store this in my calculator. Now, the easiest method to do a limiting reagent is just to try one. So I'm going to try aluminium because it's the first one I did. So I'm going to see how many moles of chromium oxide I would need if I used up every single mole of aluminium. So the number of moles of chromium oxide would equal the unknown over the known times the number of moles of aluminium. So, using our balanced chemical equation, the unknown is 1, the known is 2, times 185.32. And this comes out to 92.66 moles. Now, I need to ask myself a question. Do I actually have 92.66 moles of chromium oxide? So I go back to the actual quantity I've got, and I can see that I have 131.58 moles. So I've in fact got tons of chromium oxide. So the limiting reagent is aluminium. So aluminium now becomes our known, and we're being asked to find in the mass of the chromium produced, so that will be our unknown. So we're going to use our balanced chemical equation again. The number of moles of chromium will equal the unknown over the known times the moles of the aluminium, because that is the limiting reagent. Going back to our equation, using the coefficients, the unknown is 2, the known is 2, so 2 over 2 times 185.32 tells us that we're going to have 185.32 moles of chromium. Next step, we've got the moles of our unknown, so we're going to find the mass of our unknown, which is equal to number of moles times formula mass, which is 185.32 times by 52, and this comes out to 9637 grams. Now if you look at our original question, we have 3 significant figures there and 3 significant figures there. Now you could leave it in grams, in which case it would be 9.64 by 10 to the 3 grams, but because the question started in kilograms, we usually finish in kilograms, so it would be 9.64 kilograms. Now let's do part B. It says determine the mass of the unreacted reagent. So we want to know how much chromium oxide is left over, the excess. To do that, we first of all have to know how much chromium oxide was used. So the number of moles of chromium oxide used will equal the unknown over the known multiplied by the moles of our known, which is our limiting reagent, which is aluminium. Going back to the balanced chemical equation, Our unknown is 1. Our known is 2. So 1 over 2 times by 185.32, and it comes out to 92.66 moles, which, by the way, if you haven't noticed already, we did earlier because we luckily chose the correct one. We guessed it, so we were lucky. Now we can find the number of moles of chromium oxide left over, or the excess, which is equal to the number of moles of chromium oxide at the start minus the number of moles of chromium oxide used. Going back to the top, how many did we started with? 131.58 moles. So 131.58 minus 92.66, and this comes out to 38.92 moles. Next step, we've got our moles of our unknown. We find the mass of the unknown, which is chromium oxide, which equals number of moles times formula mass, which is equal to 38.92 multiplied by our 152, which comes out to 5915 grams. Now remember, the question was in 3 significant figures, so our answer would be 5.92 by 10 to the 3 grams. The convention says it's because we started in kilograms, we usually finish in kilograms, so it's 5.92 kilograms.